Good afternoon, dear students. Today we have to discuss load management used in DSM techniques or DSM environment. So it is already well known fact we have to concentrate the peak load condition on the power plant. In this respect, we have to discuss what is the importance of load management or load priority conditions of consumers. So it is also known that different type of consumers are there, different type of electricity users are there. Different type of consumers means agriculture sector, industrial sector and domestic sectors, different type of applications, different type of consumers, and the consumers having their choice to utilize maximum their load. That means it may be depends upon season. Sometimes cricket matches are going on or World Cup matches are going on. So it depends upon the consumer choice. As per their choice, the peak load on the power plant reaches any time of the day, that is any time of the day, that in 24 hours it may reach maximum. Otherwise it is expected go for maximum level at the 10 to 5 during office hours, during industrial hours, during your organization, during all the domestic applications we can expect, and some rainy seasons also it is fan load is low, at that time load may be low. But in winter and as well as summer season some load condition becomes very critical, because due to hot situation the consumers have to use their load daytime as well as load time, hence some it reaches the maximum. So this condition reaches the maximum load on the plant. So the operating pattern of the load decides load factor on the generation plant. The load factor is known as the ratio of average power to peak power. Hence load factor is very critical factor to decide the cost of generation per unit. It is one formula we can quote: load factor is inversely proportional to load factor. Load factor is inversely proportional to generation per cost. That means the plant operates with a high load factor, generation of cost becomes low. This electrical engineers have to keep in mind. Hence always the plant should work at higher load factor, the generation cost must be low, hence utility must be get higher benefit. If load factor on the plant is low, when this situation occurs, the operators are reduces. That means load on the plant reduces. Hence at that instant the generation cost of the plant increases. If the plant works more time in this situation, hence it may be coming under loss to utility. Hence electrical industry should get the benefit, means always we have to decide the operation of plant should be at high load factor. That means generation cost is less. And one more important fact we have to think: at the peak load operation, that is at the maximum load operation of the plant works on every electrical machines, transformers and switchgear principles are working to their maximum capacities. It is also one of the not required thing. If they are continuously operating, it will reduce the life of equipments and there is a chance of shutdown. Once there is a chance of shutdown, then it may need operation and maintenance charges, and it will affect the quality of electrical supply also. So for better electrical quality of supply, we need to operate less than peak load conditions. This is only DSM techniques informs. Some load at peak load condition, consumers are to be shifted from that to off peak load, either during the change of tariff structure, either during the change of load priority condition. Observe the diagram. It is the plot, gives the relation between generation cost per unit versus load factor. Now you can observe point number 1, if plant operates at 0.2 load factor, you observe what is the generation cost. It is approximately 0.8 generation cost per unit. Then you go on, it may be load factor is 0.4, then it reduces to 0.6. If you come to last point, if load factor is 0.8 or nearly 1, then it comes to 0.4. From observing these points, the generation cost per unit is inversely proportional to load factor. If the plant operates at the high load factor, then generation cost per unit reduces. If electric industry should work under benefit condition, then we have to get back of invested amount, then plant load factor should be always high as per the design factor. Next you can see there, this graph shows daily load curve on a plant. It is one day starting from 12 night to 12 noon and 12 night. It is, the graph is plotted for 24 hours. Depending upon the consumer's use, one example you can take from always middle night. Middle night is less load on the plant, but all resources are working with their capacity. You can observe the peak load or maximum load occurs from 9 to 5. So at this condition, all type of consumers are using their loads with their capacity. Restaurants are there, organizations are there, industry is there, agriculture is there, domestic is there, hence institutions are there. Peak load occurs on the plant. This is approximately. Hence again the load is goes on reducing. The point occurs here, at the peak load condition, power plant should not occur at this load. Some of the loads are removed. Some of the loads are removed and operated at some other time of the day. So this technique, what is the DSM technique provides? As per DSM implementation, this peak load should be shifted to some other off peak loads by giving tariffs, encouraging the consumers to shift their loads from peak condition to off peak load condition, or load management either by consumers giving opportunities by sending the signals to consumers, hence they can operate their load, or load control by utility itself, the load control by utility itself. These two options are there. If a question comes, briefly discuss load management as a DSM strategy, means you have to draw these two graphs and discuss about 2 points. Then load management techniques are there. This only you discuss. If question comes, briefly discuss load management techniques or load priority techniques, means 3 techniques are there. Those already I given in the notes. Please follow that. Only 3 you have to follow. So if this question comes like this, load management as a DSM strategy, briefly discuss, or the generation cost is inversely proportional to load factor, then you write this question and answer. Thank you to one and all.